Good afternoon, everyone. Welcome to Brain Educational Consult. So, we're going to look at binomial theorem. I'm just going to explain a short explanation of binomial theorem because of those people that are on my DM that they said they don't understand the topic binomial theorem, and those people that also said it on the group chat. So, binomial theorem is not really difficult. I don't know how your lecturer taught you, but I'm sure that it is not difficult. It's not difficult. If you pay attention to whatever your lecturer taught you, you'll see it is not difficult. So how does binomial theorem works? So if you know your expansion very well, binomial theorem should be very easy. Because if you look at this, x plus y, x plus y, x plus y, all raised to power 2. X plus y all raised to power 2, we know it to be x squared plus 2xy plus y squared. But when we want to do x plus y all raised to power a higher power, maybe like 5, I will be like, hey, how are we going to solve this? How are we going to solve this? It's not difficult. So that's where binomial theorem comes in. Like I said in the class, I said every topic in mathematics is just to solve a particular problem. Before binomial theorem, if we have x plus y all raised to power 5, we want to do x plus y times x plus y times x plus y. Like you write x plus y in 5 places. But after this binomial theorem class, you won't write it in 5 places. There is a way you can go about it. So in essence, in binomial theorem or binomial expansion, we study, as the name sounds, binomial expansion. We study the expansion of what? Of a question. That's what we study. For example, if we look at this x plus y all raised to power 2 to be x squared plus 2xy plus y squared, you will notice something. You see that the power of x here was 2. It reduces to 1, and y what increases. Then it now reduces to 0. Like here I can say y squared x raised to power 0. Understand that concept? When you want to find something, the power of something, the first one retains the power, then it keeps on reducing. The power keeps on reducing by 1. So look at it, x plus y all square. The first power reduces to 1, then now it reduces to 0. But because anything raised to power 0 is 1, while the second one starts from 0, that is the one after the sign, starts from 0 and increases by 1. So but this one, it starts from whatever power it is, then reduces to 0. This one reduces to 0. This one starts from 0. This one starts from 0 and reach the power. This one reduces from the power and end at what? 0. So take note, whatever letter that is after this sign, which is y in this case, will increase from 0 to the power, while whatever sign that is before the sign will what? Reduce till you get to what? Till you get to 0. So that is how simple it is. But now when we now do all those things, like now if we have x plus y all raised to power 3, okay, this one now, because I taught you, this one the power will be 3, this one y raised to power 0, this one the power will be 2, then y raised to power 1. Because I said it will be, this one will be reducing, this one will be what? Increasing. So this one will be x raised to power 1, y raised to power 2, and this one is x raised to power 0 and y raised to power 3. So when you simplify, this is x cubed plus x squared y plus xy squared plus y cubed. So that is it. So but what now makes binomial theorem, because once you do this you are getting it small, is another important thing you need to take note of is how to get the coefficient. So that is what will lead us to the two methods of solving binomial expansion. Because if you use this method that I taught you earlier, you just have a general concept, but you'll be able to get the coefficient. That what I'll put here, just like this 2xy now. At it being you don't know x plus y all square, and you maintain what I taught you, you will see that the first one will have this power x square, the second one will be what plus xy, and the third one will be what y square, because this one will be reducing by one, and the other one will start from 0 and increase to the power, which is 2. But this coefficient here, we won't be able to get it. So how do we solve the coefficient? There are two ways. The first way is the Pascal method, and the second way is the combination. So we'll look at the Pascal method now. Why combination will be done on Saturday. So for the Pascal method, how does the Pascal method works? Like I said, these two methods are used to get the coefficients. How does it work? We call it Pascal triangle. So this is how it works. You put 1 here. 1. Nothing plus 1 is what? 1. You start with 1. 1 plus nothing is 1. But because this one is 1, you know that anything raised to power 0 will give me 1. So this will be x plus y all raised to power 0. This second one will be x plus y all raised to power 1. The third one will be x plus y all raised to power 2. And so on. Till... So let's just form the triangle. So this one, nothing plus 1 is 1. 1 plus 1 is 2. 1 plus nothing is 1. So because mathematicians, they notice that if you add nothing to 1, you still get 1. So they usually start with 1 and end with what? 1. So they will now start adding whatever is inside. 1 plus 2 is 3. 2 plus 1 is what? 3. So this one is x plus y all raised to power what? 3. So that is 1, 3, 3, 1. So let's do another one, because I'll say nothing plus 1. And this one is 1 again. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is what? 4. So if we want to do for the x plus y all square, x plus y all square, so you see that here which one has all square? This, can you see it? This is the one that have all square. So when you do this x square that I taught you, that the reducing and increasing, so the next one will be xy. This one will be reducing the power here. This one will be increasing. This one y raised to power 0. Then this one will be y square. So but what is the coefficient? What do we have here? 1, 2, 1. So I'll put 1, I'll put 2, then I'll put 1. So that is why this one is x square plus 2xy plus y square. So if I want to do for x plus y all raised to power 3, so the same thing. What is there? 1, 3, 3, 1. So we know it to be x cubed x square y, because it will be reducing xy square, and this one will be y cubed. So what do we have here? 1, 3, 3, 1. So this one will be 1, 3, 3, 1. So that is the answer. So now let's just solve one more question before we call it a day. So this is x minus 2y all raised to power what? 3. How does this work? So like I said, the first power we what? It will be there. This one will be all raised to power what? 0. The second one, this one will be what? X squared to reduce. Take note, if you want to do the raised to power, it is the whole of it that it will be raised to the power. It's the whole of this. So this one will be minus 2y all raised to power 1. Then plus x, because the power here will reduce. Then minus 2y all raised to power 2. Then plus into bracket minus 2y all raised to power 3. So let's just simplify that. S cubed minus 2x squared y, that is x squared times 2y, then plus 4xy squared, then minus 8y cubed. But we're not done. What is the stuff for raised to power 3? 1, 3, 3, 1. So this one will be x cubed minus 3 times 2x squared y, that is minus 6x squared y. 3 times 4xy squared, that is plus 12xy squared. And this will be minus 8y cubed, because 1 times this is it. That is that for binomial. That is that for Pascal triangle. But what if we want to do x plus y or x plus 3y all raised to power 17 or 18, and they tell you to find the coefficient of, or you should even expand it, or you should find the coefficient of x squared or x cubed. That is when combination method comes in. which we will look at in the next class. So I want you guys to do this for those is that that understand what I taught. Do this and send the answer on the comment section. So x minus 2x minus 3y all raised to power 4. Expand it. So send your answer on the comment. So if you have any question or you don't understand anything, please feel free to ask me. On start today, we'll just start with combination. So if you understand what I've taught, kindly share, like, and subscribe so I can be motivated to do more. Mr. Brain love you. Bye.